Hey, a Foxtrot comic. I love these, especially when they have math. How many slices in one whole pizza? If it's pi thirds radians per pizza slice. Well, you hit pause and you can see if you can read today's specials and figure out how many slices in one whole pizza. Hit play when you're ready. Okay, I ignored the French and the logarithms and everything. Let's just focus on the pizza. So pi over 3 radians per slice. That means it's going to take 3 slices to get to the Greek letter pi, which I remember is only half of a circle. That's only half of the whole pizza. So if it's 1 slice to get to pi over 3, it'd be 2 slices to get 2/3 pi. It'd take 3 slices to get to pi, which is like 180 degrees. It's halfway around the circle. So I'm going to double that. 3 slices times 2 is 6. 6 slices per circle. All right. Hey, today we are going to continue our study of radians. So getting radians and back again. We're going to convert from degrees to radians, from radians to degrees. Um, Mainly, we'll focus on converting from radians to degrees because that's the only thing we haven't actually seen yet. So just a quick reminder here, how many radians in one full revolution? I can hear you through the screen. It took me a couple of tries there, but 2 pi radians equals 1 circle or 1 revolution or 1 pizza, whatever you want to call it. How about degrees? How many degrees in one full revolution? Try the other ear. Yeah, okay, so 360 degrees equals 1 revolution. If we're thinking direction angle, we'll rotate around 1 whole circle. Different words mean the same thing. We got to use things like revolution. This is going to be coming up in the next couple of days. It'll be important. All right, so we have these conversion factors. We saw these yesterday. If we know that 360 degrees is equal to 2 pi radians, we can set up those two things to make an equation, solve to bring everything onto one side, and we simplify the fractions. We get our conversion factors. We saw that yesterday. So 180 degrees over pi radians, that is our conversion factor to go from radians into degrees. That's what we'll be using today. And pi radians over 180 degrees, that's the conversion factor that we use to get from degrees into radians. It's the same conversion factor you're probably noticing. It's just a matter of whether it's the reciprocal. The red one and the blue one are reciprocal. So we just flip the numerator and denominator around depending on which direction we are converting. All right, let's take a quick gander at an example so we figure out which of these conversion factors to use. Okay, so the directions here ask us to convert 2 degrees. I'm given an angle in radians. We got 5 pi over 6 radians, or you could call it 5/6 pi radians. You could take the pi and the radians and just slide it right off the fraction if you wanted to. So am I going to, if I'm going to convert this into degrees, one thing I might say to myself is, gosh, I can't remember which conversion factor I'm supposed to use. I know the teacher just told me like literally 30 seconds ago, but I forgot. Okay, well, I mean, that happens sometimes. So we've got 2 conversion factors here. If I just grab one of them and bring it over here to look at it, let's see what would happen if I use the blue one. I had pi in the numerator and radians in the numerator of the original angle. And this conversion factor also has pi and radians in the numerator, which tells me those are not going to cancel. This is not going to help me get rid of pi and radians in order to convert. So this is not what I want. Toss that away. But if I were to grab this red conversion factor, I can see it has pi and radians in the denominator. So that's going to cancel the pi and radians in the original angle, which are in the numerator. As a bonus, it also has 180 degrees in the numerator, and that degrees is what I'm after. I want that unit, the degrees, to be in the numerator of my final answer. So this is the one that I want, just based on it's going to cancel the correct units. So in order to convert, I'm going to multiply straight across numerator times numerator. So that's going to be 5 pi radians times 180 degrees. I just wrote everything. I don't know that that's really very helpful, but that's what I got. And we're going to multiply straight across the denominators as well. So it's going to be 6 pi radians. And again, I just kind of wrote everything down. So maybe this is not the most helpful approach, but I think it's going to help simplify things quite a bit. Because look at this. On the numerator, I got a pi, and the denominator, I got a pi. Those cancel. In the numerator, I got radians, and the denominator, I got radians. That cancels. And then I just have numbers left and the degree symbol. So my final answer is going to be whatever 5 multiplied by 180 degrees is divided by 6. And there's probably some mental math tricks that we could use to do this. I mean, there are, definitely. But let's just multiply these. Because my calculator is hiding. So 5 times 180 is 900. And then I'm going to divide that by 6 to get 150. Don't forget the degree symbol. Hey, let's try another one. So here we've got, we're going to do a couple of examples here. Let's convert in both directions. So to start off with, convert this angle measure from degrees to radians. So I got 165 degrees. I'm going to convert that into radians. And bonus directions up here. Leave all answers that are in radians in reduced fraction form. I'll add to that, leave pi as part of your answer in reduced fraction form. Okay, so if I were to take this conversion factor that I just happen to have sitting right there, I can look at this and see that in my original angle, 165 degrees, has degrees in it. If I use this blue conversion factor, degrees is in the denominator, so degrees and degrees will cancel. That's what I want. And then it's going to leave pi and radians as part of my numerator. Super. So let's multiply. All right, so the 165 degrees is going to multiply into the top. And then in the denominator, I have 180 degrees. And I'm going to cancel these units. And then my final answer, I'm supposed to leave all radians in reduced fraction form, right? So I have a fraction, I just need to reduce it. So 165 over 180, that's really what I'm focusing my attention on. Can I reduce 165 over 180? I can see they're both divisible by 5 because they end in a 5 and a 0. I'm thinking perhaps there are larger numbers I could divide by. Maybe 15 would go into both of them. It seems like that might work. Let's find out. Let's try this. Okay, 165 divided by 15 is 11. That worked. 180 divided by 15 is 12. So 11 twelfths. That's a good guess. 11 twelfths pi radians, or you could put the pi on the top. So 11 twelfths pi radians, or you could have 11 pi over 12. Final answer in reduced fraction form. And then let's convert this angle measure from radians into degrees. So 17 pi 24ths radians is the angle that I'm given, and I'm going to convert that into degrees. So I have a conversion factor just waiting for me here. So I'm going to bring that over, and let's multiply straight across numerator times numerator. This rad is going to go onto the top. So that'll be 17 pi rad 180 degrees. And then my denominators, 24 times pi. Oh, yikes. What happened to that 4? My bad. 24 pi radians. All right. So I have some things I can cancel. Pi and pi are going to cancel. Radians and radians are going to cancel. And now all I'm left with are some numbers and the degree symbol. So 17 multiplied by 180 degrees, and then divide by 24. My final answer is going to be in degrees. Let's find out. 17 times 180, that's 3060, and then I need to divide by 24 to get 127.5 degrees. In degrees, decimals are fine. There's no provision that we have to leave decimal answers in fraction form. Don't forget your degree symbol. All right. Hey, so just as a word of warning, when you're entering answers into WAMAP, do not type the units, just numbers. So if I was going to enter this into WAMAP, this would be 127.5. Don't type degrees. For the previous answer, if I was going to type this into WAMAP, don't type radians. That is the unit. Do include pi. Pi is not part of the unit. It is actually part of the number. So you would need to type 11 twelfths pi or 11 pi over 12. You can type it either way.